Let us consider our chain rule. If you are dealing with derivative equations wherein you have, let's say, f of u, and then you have your u of x, which means that u is equal to your u of x, right? And of f of u is dependent to a variable u, and u of x is dependent to a variable x, where let's say your f of u is equal to y and your u of x is equal to u, which was stated here. We may say that y is equal to f of u of x, which means na substitute first the values of u before differentiating with respect to dy over dx, or use chain rule, wherein this chain rule states that your dy over dx is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x. So as you can see in our terms and equations, you can see that u is dependent to x. So getting the derivative of u with respect to x, will have du over dx, which is equal to the derivative of u of x with respect to dx. And also notice that in this preposition, your y is dependent with your f of u. So therefore, if you would differentiate your y with respect to u, will have a value of dy over du, which is equal to the derivative of f of u with respect to du. So po, kaya tinawag natin siyang chain rule because this is normally used for composite functions, wherein yung mga equations natin are in the set of change, or in chain I should say, wherein they are interconnected with different with variables that are related to each other. Okay, so yan yung tinatawag nating composite function. So therefore, the derivative of a function with it wherein it is dependent to a composite function, so we may apply our chain rule, wherein we'll first get the derivative of the main function with respect to u, okay, and then derivative the function at u with respect to x, if you would want to get the value of our dy over dx. So from here, we may say that the derivative of u with respect to u is equal to 1. So therefore, we will come to a conclusion that is equal to dy over dx. Another solution for this composite function is that, as I have said, so pag meron kang function na y is equal to u of x, okay, or f of u. So y is equal to f of u, and we all know that y is equal to f, wherein u is dependent to u of x. Okay? So therefore, ang gagawin mo dito, substitute mo muna yung value ng u of x mo sa value ng u mo before differentiating. That is the second solution. But probably, may mga solution kasi na pag nag-substitute ka ng value ng x agad before or not using your uh, chain rule, mas mapapahaba yung equation mo. So that's why we have our chain rule. Okay? Which is also equal to dy over xn. So that is our chain rule. So this is a theorem, or this is a rule in solving equations with composite functions with interrelated variables. Okay, so let's have our example. Okay, so let's have our example number 1. So as you can see, let's have the first equation wherein y is equal to u squared plus u, and our u is equal to 2x plus 1. As you can see, in this equation, your y can be written as f of u, wherein this is dependent with your u, which is equal to u squared plus u. And also, your u can be written as u of x, which means that it is dependent to x, which is equal to 2x plus 1. So, if you would apply the chain rule, you will have dy over du, which is derivative of f of u with respect to u, which will lead to the derivative of u squared plus u with respect to du, which is equal to 2u plus 1. Okay, power rule. So in that scenario, we will have our dy over du. By solving our du over dx, okay, so we have u of x is equal to 2x plus 1. So getting dx, du, I should say, du with respect to dx, will have a value of du of x with respect to dx will have the derivative of our 2x plus 1 with respect to dx. So we'll have du over dx equals positive 2. Okay, so upon identifying that one, let's use our chain rule in solving the problem. We'll have du over dx multiplied by our dy over dx. Take note that our du over dx is equal to 2 multiplied by our dy over dx, which is equal to 2u plus 1. So from this, we'll have dy over du to. Okay, so from this, we'll have du divided by du, or du, the derivative of u with respect to u is equal to 1. So we'll have a function equal to dy over dx, which is equal to 2 multiplied by 2u plus 1. But take note that our u is equal to 2x plus 1. So therefore 2 multiplied by, substitute natin yung value ng u natin, which is equal to 2 multiplied by 2x plus 1. Of course, this is plus 1. So therefore we'll have 2 multiplied by 4x plus 2 plus 1, which is 2 multiplied by 4x plus 3. So this is the demonstration of our chain rule. How about if we would directly substitute the value of our 2x plus 1, which is equal to your u? So probably you can use that by y is equal to u squared plus u. Since u is equal to 2x plus 1, I may say that y is equal to 2x plus 1 squared plus our u which is equal to 2x plus 1. So, bakit po ginawa yan? Because I have initiated that my u is equal to 2x plus 1. Okay? And also, it came from our problem. So, by demonstrating that dy over dx at f of u dx wherein u is equal to u of x, so we'll have f of u of x dx will have this value. So factoring out your 2x plus 1, we'll have y multiplied by y is equal to 2x plus 1, so we'll have 2x plus 1 2x plus 1 squared divided by 2x plus 1 will have 2x plus 1 plus 2x plus 1 divided by 2x plus 1 is 1. So therefore we'll have a value equal to 2x plus 1 multiplied by 2x plus 2, which is equal to our y. So getting its y prime using our product rule, we'll have y prime is equal to u dv plus v du. Okay, so from this we'll have u which is equal to 2x plus 1 and our b will be equal to 2x plus 2, so we'll have 2x plus 1 multiplied by the derivative of 2x plus 2 divided by dx plus our v which is equal to 2x plus 2 multiplied by the derivative of 2x plus 1 with respect to dx, will have a value equal to 2x plus 1 multiplied by derivative of 2x is 2 plus 2x plus 2 and the derivative of 2x plus 1 is 2. So we'll have 2x plus 2 multiplied by 2 will have a value equal to 4x plus 2 4x plus 2. Okay, so plus 4x plus 4, ayan, or actually ang gagawin natin, ilabas natin yung 2, will have 2 multiplied by 2x plus 1 plus 2x plus 2 pag inabas natin siya. So we'll have a value equal to 2 multiplied by 4x plus 3, which is parehas lang siya. Okay, this is our example number 1. Example number 2. So let's have y is equal to square root of u squared minus 1, wherein your u is equal to 4 square root of x. Okay, so how about if we would use our first preposition, wherein our y is equal to, substitute natin yung value natin dito, wherein we have f of u of x which is equal to square root of our u squared minus 1, which can be written as square root of 4 square root of x squared minus 1. So we'll have a value equal to square root of 4 multiplied by square root of x squared, or 4 squared multiplied by square root of 4x squared minus 1, which is equal to square root of 16x minus 1. So getting the derivative of this one, we'll have 16x minus 1 raised to 1 half, which will have 1 half multiplied by 16x minus 1 raised to 1 half minus 1 multiplied by the derivative of our 16x minus 1 with respect to dx. Note that this comes from our power rule, which is n u raised to n minus 1 du over dx. Okay, so from this we'll have a value equal to 1 half multiplied by 16x minus 1 raised to negative 1 half multiplied by 16, or it is equal to 8 divided by square root of 16x minus 1. Okay. So, or using our chain rule, we'll have dy over du, which is equal to the derivative of square root of u squared minus 1 with respect to du, I should say. So therefore we'll have a value of u squared minus 1 raised to 1 half, or we'll have a value of 1 half u squared minus 1. So 1 half minus 1 multiplied by the derivative of u squared minus 1. Okay, from our power rule, which is n u raised to n minus 1 du over dx. So from here we will have a value equal to 1 half multiplied by 1 over square root of our u squared minus 1, kasi nga 1 half minus 1, tama? So multiplied by the derivative of u squared minus 1 will be 2u. Okay, so cancelling out your your u, kasi your 2 I should say, kasi nga magiging ko lang to, magiging 1 lang yan. So you'll have u divided by square root of u squared minus 1. Okay, so next is that we have our u equals 4 square root of x. Okay, so du over dx will be equal to 4 multiplied by 1 half multiplied by x raised to 1 half minus 1 multiplied by the derivative of x is equal to 1, or lagay ko na lang dito dx over dx. So we have value equal to 2 multiplied by our 1 over square root of x multiplied by the derivative of x is equal to 1. So getting our dy over du, so dy over du, which is equal to u divided by square root of u squared minus 1, so multiplied by our du over dx. So du over dx will have a value equal to 2 divided by square root of x. So substituting the value of u, okay, wherein our u was initiated as square root of 4x, so therefore we'll have square root of 4x, okay, 4 square root of x I should say. So 4 square root of x multiplied by 2 divided by square root of multiplied by square root of x. So therefore we'll have a value equal to square root of x divided by square root of x is equal to 1. So 4 multiplied by 2 is 8, and square root of 4 squared is 16, and square root of x squared is x minus 1, which is parehas lang sila dito. Okay, that is our sample number 2. Okay, so example number 3, we have y equals u minus 4 raised to 3 halves, and our u is equal to x squared plus 4. So dy over du will have a value equal to 3 halves multiplied by u minus 4 raised to 3 halves minus 1, the derivative of our u minus 4 du. Okay? So note, in-apply ko diyang formula is our power rule wherein n, u raised to n minus 1 du over dx. Okay? So, from this, we'll have a value equal to, so bakit dx to, du to? So, note that we are differentiating the value of dy over du with respect to our u. Okay? So, yan. So, from this, we'll have a value equal to 3 halves multiplied by our u minus 4 raised to 3 halves minus 1, which is, this can be solved as 3 halves minus 2 over 2. Tama? Multiplied by the derivative of u minus 4 is the derivative of u is equal to 1 and the derivative of 4 is 0. So multiplied by our 3 halves multiplied by u minus 4 raised to 3 halves minus 2 over 2 is 1 half. So equals 3 halves multiplied by u minus 4 raised to 1 half multiplied by 1, or this is equal to 3 halves multiplied by square root of u minus 4. Right. So our du over dx, okay, so this is our dy over du, and then we have our du over dx, wherein the derivative of u with respect to x will be equal to the derivative of our x squared plus 4 with respect to dx, which is equal to 2x. Okay? By further manipulation of this equation, we will have du over dx multiplied by dy over du, which is our du over dx is equal to 2x and our dy over dx is equal to 3 halves multiplied by square root of our u minus 4. Okay? But what is our u? Okay? So note that our u was initiated as x squared plus 4. So therefore, we'll have a value of 2x multiplied by 3 halves multiplied by square root of x squared minus 4. X squared plus 4 as our u minus 4. Okay? So positive 4 minus negative 4. Positive 4 minus 4 is 0. So therefore, we'll have a value equal to 2x multiplied by 3 divided by 2 multiplied by square root of x squared, which is equal to our 3x multiplied by square root of x squared is x. So we'll have 3x squared, which is equal to our dy over dx. Okay. So, example number 4. We have y equals 2u minus 2 raised to 2/3 and our u is equal to 4x cubed plus 1. Okay, so dy over du is equal to 2/3 multiplied by 2u minus 2 raised to 2/3 minus 1 multiplied by the derivative of our 2u minus 2. Okay, so from this we will have a value of 2/3 multiplied by 2u minus 2 raised to 2/3 minus 3 over 3. So multiplied by the derivative of 2u is equal to 2 minus the derivative of 2 is 0. So therefore we will have a value of 2/3 multiplied by 2u minus 2 raised to negative 1/3. Diba? So multiplied by our 2. Okay. Next is our du over dx is equal to 3 multiplied by 4x squared, which is equal to 12x squared. Okay. So therefore we'll have dy over du multiplied by du over dx, so which is equal to 2/3 multiplied by 2 multiplied by 2u minus 2 raised to negative 1/3 multiplied by our du over dx, which is equal to 12x squared. Okay. So from here we will have a value equal to 4/3 multiplied by 12x squared, okay, multiplied by 2 multiplied by u, which is equal to 4x cubed plus 1 minus 2, okay, raised to negative 1/3, or we will have 4 multiplied by 4, okay, so multiplied by x squared divided by the cube root of our 2. So factor at going to 2, we'll have 4x cubed plus 1 minus 1. So 1 minus 1 is 0, so we'll have a value equal to 16x squared divided by cube root of 2 multiplied by 4x cubed. Take note that we'll have 16x squared divided by cube root of 8x cubed, wherein we'll have a value equal to 16x squared divided by 2x, or it is equal to 8x. Okay. Yan. This is for our example number 4. So our example number 5. Okay, wherein we have y is equal to square root of u plus 2, and our u is equal to 4x minus 2. So if we have y is equal to u plus 2 raised to 1/2, okay, so wherein we may say that dy over du is equal to 1/2 multiplied by the derivative of u plus 2 raised to 1 half minus 1 multiplied by the derivative of our u plus 2 with respect to du. So from this we'll have a value equal to 1 half multiplied by u plus 2 raised to 1 half minus 1 is equal to negative 1 half the derivative of our u plus 2 with respect to du. So wherein we'll have a value equal to 1 half multiplied by u plus 2 raised to negative 1 half multiplied by the derivative of u plus 2 is 1 plus 0. So therefore we'll have a value of 1 half multiplied by 1 all over u plus 2 raised to 1 half. Also, since our u is equal to 4x minus 2, so therefore we have du over dx is equal to the derivative of 4x minus 2 with respect to dx, so we'll have 4. Okay, so from this we'll have our chain rule, which is equal to dy over dx, which is dy over du multiplied by du over dx, which is equal to 4 multiplied by our 1 half multiplied by 1 all over u plus 2 raised to 1 half. Okay, so we'll have a value equal to 2 divided by square root of u plus 2. Note that our u is equal to 4x minus 2. Okay, so therefore we will have a value equal to 2 divided by square root of 4x minus 2 plus 2, which means you will have a value equal to 2 divided by square root of 4x. So 2 minus 2 is equal to 0, so therefore we will have 2 divided by 2 square root of x. So cancelling out your x, you'll have a value of 1 divided by square root of x. Okay, which is equal to your dy over dx. Example number 6. Let's have y equals 2u divided by u squared minus 1. Okay, so from this we will have a value equal to, and our u, I should say, is equal to x squared. So from this we will have a value equal to dy over du is equal to the derivative of 2u over u squared minus 1 with respect to u. So we will have a value equal to u v du minus u dv all over v squared, wherein we'll have v, which is equal to u squared minus 1 multiplied by the derivative of our 2u with respect to du minus 2u multiplied by the derivative of our u squared minus 1 all over our v, which is equal to u squared minus 1 with respect to dito. So by further manipulation of the equation, we'll have a value equal to u squared minus 1 multiplied by the derivative of 2 is equal to 2 minus 2u multiplied by the derivative of u squared minus 1 is equal to 2u divided by our u squared minus 1. Okay, so here, just take note that this is in square, no? So dapat naka-square to. Ayan. Okay. So from this we'll have 2u squared minus 2 minus 4u squared divided by u squared minus 1 squared. So 2 squared minus 4 squared will have negative 2 squared, wherein we have negative 2 minus 2u squared divided by u squared minus 1 squared. This is our dy over du. Okay. For our du over dx, we have u is equal to x squared. So du over dx, we have 2x. Okay. So by further manipulation of the equation using our chain rule, we have dy over du multiplied by our du over dx, which is equal to negative 2. Lalabas natin yan. We have 1 plus u squared all over u squared minus 1 squared multiplied by our 2x. But what is our u? Our u was x squared, wherein we have negative 2 multiplied by 1 plus x raised to 4 all over x raised to 4 minus 1 squared. Okay. So multiplied by our 2x. Okay. So from here we'll have a value equal to negative 4x multiplied by 1 plus x raised to 4 divided by x raised to 4 minus 1 squared, which is our dy over dx. Okay. Example number 7. Let's have y is equal to square root of u and u is equal to square root of x. So dy over du is equal to u raised to 1/2, which is n u raised to n minus 1 du over dx, which is we have 1/2 u raised to 1/2 minus 1, the derivative of u with respect to du, which is equal to 1/2 u raised to negative 1/2 multiplied by 1. Okay. So we'll have a value equal to 1/2 multiplied by 1 all over square root of u multiplied by 1. So from this we'll have a value of 1 all over 2 square root of u. Okay. For our example number 8, for our u, we'll have u is equal to square root of x, so therefore du over dx will have x raised to 1/2. So the derivative with respect to x will have 1/2 x raised to negative 1/2 dx over dx, which is 1/2 multiplied by 1 all over square root of x multiplied by 1. Okay. So from here we'll have a value equal to dy over du multiplied by du over dx, which is equal to 1 over 2 square root of u multiplied by du over dx, which is equal to 1/2 multiplied by square root of x. So by further manipulation of this equation, we'll have 1/4 multiplied by our u is equal to square root of x, so 1 over square root of u, which is equal to square root of x multiplied by our 1 over square root of x. So take note that we have 1/4 multiplied by x, 1 all over x raised to 1/4 multiplied by 1 all over x raised to 1/2, which means you will have a value equal to 1/2 plus 1/4. We have 4, 1 plus 2, we have our 3/4. Okay, so we have 1/4 multiplied by 1 over x raised to 3 over 4, which is equal to dy over dx. Okay, that is our example number 7.